And welcome to our 19th meetup, C++ meetup, San Diego. My name is Kobe. I'll be hosting the meetup today. And first of all, I just want to see if there's anyone. Just raise your hand, like the virtual hand. If you are new to the meetup, it's first time for you. Just want to get some clue about who's new. Okay, I see couple. Okay, welcome. I'm happy to have you. I have my regular first few slides where I explain what do we do and what do we want to achieve and so on and so forth. I have, you can ask things in the chat if you can't. I have the Slack channel also open. So let me start. We have a lot of things to cover today. And 1 second. Okay. So again, thank you, Qualcomm WRD Software, the group that I'm working in. They're paying our meetup fees and supporting us, so thank you for that. So here's the kind of the pitch that I have every meeting in the past almost couple years. We are looking for people to have a talk in this meetup. It can be anything that you can think of. There's a lot of topics out there for that you can pick one and talk. And I'm here to help you if you want to step up and have something to present. There's a lot of things that are recently available. C++ 20, for example, is a new standard, and the CPPCon just finished, and there's a lot of ideas that we can use to get new talks and new material. You don't need to be an expert. You'll become expert when you pick a specific topic and talk about it and explain it. So that's the way I see it. So the agenda for today would be the following. So we'll have our GitHub repo of the month, and I picked Google Benchmark. If you're familiar with that, that's a very useful one that you can use to benchmark your code. We'll have a lightning talk. So it's a lightning talk from last CPPCon 2019 that I attended. It was very funny and interesting. LeetCode and algorithms. Actually, I have a lot of things to present in this specific subsection. We have 1 Stack Overflow, 2 C++ quiz, 1 book recommendation, and we'll continue the Lambda workshop. There is another thing that it's not mentioned in here, which is kind of an announcement related to the next meetup. We'll get to it soon. I just want to make sure that I see everyone. If you have any questions, just unmute yourself and feel free just to kind of speak up, okay? Okay, so and sponsored by Qualcomm WRD Software, thank you. This is our Dropbox. I'm uploading the slides to this folder, and we have our own Slack channel. We also have a YouTube channel that we upload our recording. We have a Twitter account. This is the handle. I'm managing it. This is and Kobe_CA is my Twitter handle that you can follow me. I tweet mostly about C++, software engineering, Python, Linux, Unix, Rust, and everything that in between that looks interesting, at least to me. No politics, by the way. I'm avoiding politics. So I'm just trying to keep it very neutral. Okay, so announcement. So this is I think a very exciting announcement that I would like to share with you. So there is a company named Secure Code Warrior, and they approached me a couple months ago, and they have a platform to kind of train people to write secure coding. And the way it works is the following: it's similar to LeetCode or similar platforms, but not quite the same. You'll get, and I'll show you an example. There are a couple of videos. So you'll get. So it's a tournament. So and it's going to be next month. The same time that the second week of the second Tuesday of the month. We'll have it 4 hours. So it's gonna. So I think 2 hours would be too short for that. So it will be like around 4 hours because there's gonna be some introduction and all. It's gonna be between 5 to 9. This is San Diego, like West Coast Pacific Daylight Time. So the idea is that you're competing with others. You'll get a snippet of code, and you need to detect what is wrong. And it's all, so they gave me a tutorial, like it gave me a demo. It's all modern C++ related, and it's pretty fun. So the platform is really fun to work with. And then you have opportunity to learn and to fix it, and you get hints if you need to. And I think it's gonna be very fun to have. They usually have it in person, but we have everything today in a virtual environment. So and the nice part, by the way, they have the platform is capable of multiple languages. So almost everything that you can think of, language. So they have C, Python, C++, Rust, C#, Java, and so on and so forth. So it's a very nice tool. It is of course, if you want to start using it, it is paid. So you need to pay some subscription, just like you have LeetCode, and also you need to pay if you want to get the premium features. So let me just make sure that I share with the audio so I can. Okay, so let's see. Hopefully you'll be able to hear. Actually, I'm unable to hear. I don't know if you can hear. Can you hear anything?
No, we are not able to hear it.
No, me too. I don't know why.
Not me.
Yeah, I don't know why. Can't hear it. 1 second. I'm using a new environment, my son's environment. He gave me his room, so things a bit different today. 1 second. I'll give it another shot. Okay, 1 second. Let's see. Yeah, I'm not sharing anything. I'm just trying to see if it's related to but I don't actually, I can't even hear it. 1 second. Okay. The links are there, so you'll be able to use it. I'll reshare one. Give me a second. I'll reshare my screen. Okay, so let's do this. I still want you to watch at least the 2 minutes video. So it's not gonna be you're not gonna hear anything, unfortunately, but at least you'll see how it goes. So this is where life used to be regular, where we used to meet. So you have this this interface where your screen is split and you can see what's wrong with the code and try to fix it. And sometimes it's in groups. We're not gonna have any groups, but yeah. Anyway, since there is no sound, you got the idea. Hopefully, I'll see you next time. I think this is gonna be super fun. So it's not gonna be the regular meetup agenda. And I think the problem would be that I think I'm not gonna be able to. You can hear me, right? You still can hear me, right?
Yeah, we can hear you.
Okay, so give me a sec. There is a message from Teams to help me with that one. 1 second. Okay. Okay, I want to give it a try again. Let me see. I can hear it. Can you hear? Yeah.
You're about to become a secure code warrior.
But you don't see it, right? You don't see it because I'm not sharing it. 1 second. I'm going to share the browser now. Okay.
Although you're now in a gamified environment where you'll compete against fellow developers and aim to finish on top of the leaderboard, this is more than a tournament. This is an introduction to a bold new way of learning, more interactive, more engaging, encouraging you to build and test software with a security mindset. As a secure code warrior, you'll face a series of challenges and missions during this tournament. You'll be given strings of code that may or may not contain vulnerabilities. Your challenge is to locate, identify, and fix each vulnerability. If you need help, we'll give you a hint. But a friendly warning: the more hints you take from us, the less points you can obtain. If you get it wrong, we will give you 1 or more chances to retry at a reduced point value. So the decision is yours to try or get help, something to remember as you face each challenge. Are you ready? It's time to start thinking like a secure code warrior. To do that, follow these steps to register for this tournament. Enter these details into the URL bar.
So you don't need to do anything. I already took care of the whole arrangement, so just ignore that. Okay. I think it's exciting. I think it's going to be fun. Hopefully, I'll see all of you joining. Get back to, and you can watch the other one. If you just Google Secure Code Warrior, you'll get enough information. Okay. The GitHub repo of the month, again, taken from Awesome C++, cpplibhunt.com, which I subscribe to. It's a very fun newsletter. You get like kind of a weekly digest of all kinds of nice libraries and articles that kind of highlighted in the past week. Very useful to kind of adapt in your code base, and pretty recommended. I have a feeling that most of you probably familiar with, or at least heard about that. Just encourage you to try it out. Okay, the next one would be the lightning talk. It was pretty fun watching that, and I'm going to share again my my browser. Okay. Let me know if you don't hear it. If you don't hear anything, let me know.
It's time to speak up also for the underappreciated language features. I've been all the years noticing that there's a lot of...
By the way, this is a great guy. He's from Germany. He runs Meeting C++. If you go to Google Meeting C++ and you follow him in Twitter, he's like a great guy. He's doing tons of stuff for the community.
Folks around at our conferences who don't like macros. And I thought maybe we could, make them a bit better if we improve macros and make them a bit more modern C++, okay? So actually, I had this idea for this lightning talk at C++ Now, which is in Aspen, just behind the mountains in spring, but I couldn't kind of give the talk there because I couldn't write it in the time. So I thought I'd give it here at CPPCon. Yeah, macros are actually something which, has been a big debate. I think the last big debate with macros was modules and some other things. And so I decided kind of to give a lightning talk on this and to show you some, how macros actually are in our language in a different way. So I quite understand that not everybody likes macros. And then sometimes it gets worse. And on the other hand, there's also, macros have their positive and their good side. They have preprocessor magic. Boost preprocessor does wonderful things and has really enabled to do great things. And then on the other side, Qt and a lot of other frameworks use this, and it's a great language feature, actually. But actually, if I'm honest, it's just fancy text replacement. That's all there is. And just imagine if you could put that in the standard. If that would not be anymore in the preprocessor, but if we would use that, the power of text replacement in the standard to generate code in the standard. So I just have a question to the audience. Who thinks standardizing macros like that would be a good idea? Okay. Okay. One hand, thank you. So you probably don't think that the community would standardize something like that, right? I have bad news for you. You're already too late. It's already there. So let's think about some random characters. And actually, if you take a look at that inside cpp.io, you find out that lambdas are a lie. Lambdas are macros. It's text replacement. The compiler it's not the preprocessor, it's the compiler, and though your code is actually something else, what you see there. So it's use of text replacement to make the language better. And if you add auto, the whole code changes, and you can play around with that. And you're amazed how much text replacement and a lot of what things are hidden there. And I guess a lot of folks didn't know that until now. So this is like a modern use of what macros are supposed to do. But now you're thinking, it's lambdas, one feature, that's okay. But wait, there's more. Ranged 4. Ranged 4, there's nothing else to give you a raw loop, which is a bit fancy hidden. But that's okay, because the ranged 4 is actually doing what a transform does, or for each, and shown parent is okay with that. Auto. Auto is also text replacement in the kind of sense. So if we get to see this, modern C++ macros are actually compiler driven, and they're designed by the committee, and they're like some of our most modern features in the last years actually have enabled us to write C++ in a shorter way and still have the compiler understand it in a standard conformant way. Thank you.
So yeah, it's just a few things, but it's just a fancy macro. So and we'll see it when we talk about Lambda. Okay, let's continue. Okay, the next thing is I have this section where I talk about better algorithm intuition. Again, it's inspired by Connor's orchestra talks, and he has blogs and tweets and all of that I'm following, and is all about functional programming in multiple languages. And I say it every time, I say it again. I encourage you to talk either CPPCon or any of the recent ones, and take a glimpse of what he's advocating for. So this time I actually want to go back to a previous algorithms that I showed, and I don't remember when this was, but so you know what I'm going to do, I'm going to share my entire desktop. It's going to be easier for me. Okay. So so there was so in September 8th, I think it was right at the same day that we had the meetup, and he showed my solution. And it was kind of, there was a thread, and someone named Darrell, I think this is his name, had a nicer approach using stud equal. And I really liked it, and I wanted to present that to you all. So basically, this is just a bigger font that just kind of screen capture it. So this is again palindrome and of an integer. So you're doing toString, and then you want to check if it's equal from begin all the way to the half of it, right? So you do stud next of these steps, and then begin to the half of it. And this was, I found a very cool solution. Yeah, I completely forgot when I looked at equal. I used stud next and all in my solution, but equal is really nice algorithm to remember. And the idea is really to remember what's out there. to make the connection that this is a good solution. So and you can follow him. This is his Twitter handle. He tweets a lot about C++. So okay, so that's one thing. And then I had another solution. I think that the month before, you can definitely see that people actually do something with my solutions and put it on the web. So there is a guy named Leslie Lay, which again, he's a great guy. He's tweeting a lot about C++ and very interesting stuff. So this is his blog. And he had he wrote a page about beware of passing mutable lambda to the STL algorithms, and he took my example as a not the best example of how to use std find if, and I totally agree. So he had this lead code, and this is of course my name to my Twitter handle, and his point, which I completely agree, I actually didn't feel comfortable with all of that, so I just want to kind of show that to you, that this is not probably the best way to solve, because I was trying to shove a lambda with a lot of mutable stuff into find if, and really find if is not the best algorithm. But the thing is, there is no best algorithm, and I had an offline discussion with Leslie about what's the best approach, and sometimes the best approach is just having a for loop, and I'm convinced this is I totally agree here. Sometimes there is no proper way to fit it into a standard algorithm, and in some sense, if you think about a standard algorithm themselves, they have some loops. So maybe this to some, we could generalize it to something else, not to some, but something else that we could use in different problems. But I want to give you another angle of try not to use a lot of mutable, like this is a lot of mutable stuff. And this is just a simple for loop that eventually does the same thing, and it uses the same techniques, the same runtime, but it's probably more it fits more to a for loop than a find if with a mutable lambda. And he had more examples of other stuff that you can read. I have the page in the meetup, so you can try it out and take a look. Okay, the next thing would be this one. Okay, let's take a look. Okay, so there was a question in Reddit. How do you take the array and copy that to, let's say, a vector? So there are multiple ways to do it, and one way that I had is very simple. You just copy that to a back inserter and be done with it, right? Super simple. So you have this vector and all. And I was like asking, hey, what about ranges copy? Like, how would you do that? So there was a thread that is captured in the slides. You can go back, and so again, Darrell, which I mentioned in the previous one, had an example of how to use it with stdspan. So stdspan gets an argv and argc, and then transform that to strings, each of them to strings, and then pipe it to vector. This is with using ranges. This was my question. How would you make it to ranges? And this is a neat way. So the missing part was like the span, which I tried all kinds of stuff. Like transform to string and pipe it to vector was the solution here. And you can read the various things in the thread. It's kind of an interesting idea. Okay, and it is a bit on the more advanced because we didn't talk a lot about stud ranges. We just mentioned it here and there. But okay, the last thing I wanted to show is another leet code, another palindrome, but now with a linked list. So there is this leet code question where they have this structure. It's basically a singly linked list, like what we call like a forward list, and if you have, let's say, 1, 2, 2, 1, that's true, right? So and the link to the question is here, and what I did is let me take a look in here. So I have it just in a either on my C line, or you can take a look at the GitHub. But basically, this is the definition. The solution is that I found, again, is very straightforward. I find the middle, and I use equal on both. The only I need to flip, so I need to flip from the middle all the way to the end in order to get to be able to traverse from the start and from the end. And I need to flip back because what happened is the leetcode engine actually tries to free and newly they knew the node, so need to flip back to the original position so everything is happy. But the idea is really simple. You just find the middle, you flip it from the middle all the way to the end. So I can actually now have the end and the head, I can run equal. But the thing is that I needed to write some helper functions, and the equal is really simple. Like I'm just checking from 2 iterators, and it's the regular singly linked list from school that you can think about. So I wrote stuff like count until, which is very similar to what you will see in the standard, for example, advanced. But the standard doesn't have this notion of this specific list node type. So I needed to rewrite this thing in order to get a very simple. The thing is that if I want to, I could take all of that and make it a library. So next time I have something like this list, I can reuse it. So this was accepted, and this is my kind of unit test in the mains. And when I put it in leetcode, this was accepted without any issue. So that's it from the leetcode part. And you have all the information in the slide, so you have it. Okay. I found a very interesting Stack Overflow question that I found it to be very interesting to present. Is it undefined behavior to iterate over an std array initialized in the for loop? Okay, and so we can take a look at the actual question. So you have this for loop, and it says, okay, it yields the following incorrect value. But if you have this, it would yield the right thing. So the question is it undefined behavior, or is it a compiler bug? Was it a compiler? Oh, it's a Visual Studio. So Visual Studio gives at least this version. This is from September 9th edited, so I don't know. Yeah, it was asked in September 9th. And No, it's not an undefined behavior. It does extend the lifetime of a temporary range. So basically, this is probably a Microsoft Visual Studio Visual C++ bug. So you should not see this, and for range loop would extend the lifetime of this std array, which is good to know. It's good to know that that's possible. So this is valid. Okay. Okay, let's talk about C++ quiz. I have a couple of them. And this is where you chime in and think what is your opinion on that? Okay, so we have two functions. This is C++ 17, the lowest difficulty level. Two overloaded functions, one with integer and one with unsigned int. It's 1 or 2, and we're passing a negative double. So shout, what do you think is good? So, and I don't know if you're familiar, remember, but it's either the program is compiled and it's guaranteed to output something, or it's a compilation error, or it's undefined, or it's unspecified or implementation defined. So what do you think happens here? And the question boils down into, can a double fit to an int, to an unsigned int? Would one of them be preferred? Are they equally preferred? So if one of them preferred, we'll see either 1 or 2. If they are equally preferred, like they have the same rank and all, then it's not going to compile. So basically, these are the two options. Well, there's also undefined and all, but I'm not sure it's undefined. Anyone wants to guess? It's okay to guess. No? Okay, so as far as I remember from my memory, it's not going to compile. They are equally good. Let's see if I remember it correctly. Yes. Okay. And there is an explanation why. So both double to int and double to unsigned are type floating interval conversion, which has one conversion, and basically they are equally. So no conversion is better than the other, so the program cannot be compiled. It's ill-formed. It's the whole conversion and promotion and ranks is very important to understand how C and C++ working. C++ inherited this whole thing from C. And it's a very important aspect to know. Okay, next one. So this is C++ 17, medium difficulties. So we have a class and two functions. One is the constructor function, one is the destructor. A and capital A, that's what we print when, and we just have a global namespace I initialized with 1. We have an integer, we have the main function returning int, label because we have a goto. Yeah, it's evil, but this question tries to exercise something related to goto. So, so we have a label. Then we have a construction of A. Then we check I is 1, and then we do minus minus. So if it's 1, it's okay. We go to the label, so we go back here. We do this, and then it's 0, and we're done. So the question is really, what happens to the A instance? Is it going to be, there are at least two options. One, it's constructed, or it's constructed and then is goto guaranteed to distract everything that is in the scope? That's the question. Any guesses? You do hear me, right? Just want to make sure.
I was wondering if goto would destroy the A. I'm guessing it wouldn't. It would just like jump. So I'm guessing it would just print lowercase a twice, and then it would only call the destructor once. I might be terribly wrong here, but
so I was actually guessing this the first time that I tried it, and I was wrong. I actually remember that there is something funky with goto that it's not guaranteed to distract. I remember something because I'm not using goto, so my memory kind of erased all the pitfalls of goto. So, and I remember there's something very sorry, very bad with goto. So I initially did this. And this, because I thought that it's gonna be maybe something very other funky, but I tried with this. But this is like, because I remember there is a gotcha here, but actually there is no real gotcha. It's like it's actually destroying it twice. Like it constructing and distracting, constructing and distracting, just like it was another scope. So oh, it's actually incorrect. So I don't remember how. So let me try it again.
I think that's just,
I did the other way around. Sorry.
Yeah. Okay.
Okay. So the so this is the explanation. So automatic storage duration involves the destruction of the object with automatic storage duration. They are in the scope of the point of transform, but not at the point of transfer to. So so that's there is some gotchas, and I'll try maybe to find some for next time as a follow-up, unless someone has any stories from goto that he or she was bitten by when using it. See what the CPP Insight is doing. Nothing special. Okay. Okay, book recommendation. Learning C++ functional programming by Wisnu. I don't know how to pronounce the name. Look, in my opinion, if you look at the rating, either in Packet or in, I actually read it back to back. There is one chapter of lazy evaluation that is a bit hard. If you know C++, it's gonna be fun to read. If you don't, this is gonna be a very good, in my opinion, book on Lambda. It's full of Lambda, lots of examples. There are some typos, by the way, and I need to, it's on my to-do list to go back to Packet and make sure that they fix it for the next edition or something like that. But I felt like it was a very good book. It takes a few days to read it, not more. I think not more than 4 or 5 days. It's not like a huge book. It talks about everything about functional programming, lazy evaluation, tail recursion, memoization, which there was like nice stuff, functional programming, concurrency. Again, the reviews are not the best, but I actually enjoyed reading the book. So I definitely wanna recommend if you have a chance to. This is full of Lambda and lots of good examples, in my opinion. And at least the 4 first chapters are really easy to digest. Then it goes into lazy evaluation and all, which is a bit on the tough part of this domain. Okay, last thing before we go to the we continue with the Lambda part. So how not to pre-allocate space for std vector in C++. I must say that I was bitten by that at least once or two in my career, at least. It's very annoying. So take a look at the left part. So you think, oh, I'm going to allocate storage for 3, and then I do pushback, right? I want to have 0 on 2. But what happens if you set this 3, you have a vector allocated with size 3 at least. The capacity would be at least, we don't know how much the capacity, but the size would be 3, and the end pointer would point to the one past the 3, right? So it's the end point. So when I push back, I push 0, 1, and 2. This is the wrong way to do it. What you want to do is you want to reserve this, only reserve capacity. So it's gonna reserve or allocate at least 3 elements, might be more, but at least 3 elements. But the size is 0. So the end pointer would still point to the first allocated one. So when I do pushback, this would be 0, 1, and 2. So this is what you have. Now, there is a better alternatives. There are a couple of them using STL. There is the Std iota, where you can say, hey, I want to populate. So here you actually allocate and have the size of 3. And so from begin to end, I want to start populating starting with 0, 1, and 2. So that's what you have. So iota would give you from, let's say you want to start with 0, so 0 all the way. So it's going to populate that until the end. So if I start with 1, it's going to be 1, 2, 3. So this is a very nice thing. And generate basically is the same, but it's kind of more verbose from begin to end. And there is a mutable lambda here that's just doing an n++ just to get the because this n, and we'll talk about mutable in the next section of the meetup. Okay, that's what I had for this part, and I want to go to. Okay, so before I continue, is there any question or comment or anything that people want to bring up before I, like in what we had in the previous section? The previous section is kind of mixed with all kinds of levels, but you'll have the slides, and you can go over the links and ask questions either in Slack or I think Slack is the only thing that we have, and you can always contact me in Twitter or things like that. Okay, yeah, you can definitely ask questions as we go. Okay, so okay, let me ask that before I continue. Who missed the previous session? I want to see how much I need to kind of have it, like a 10, maybe 5 minutes of recap. Just raise your hand if you missed the previous section. Okay, so there's few people. So for you, I'll do the following. I'll do it super casual. Look, Lambda. So going back to this CPPCon 2019 lightning talk that I showed a few minutes ago. Lambda is like a compiler macro. It really makes life easier. So it's a callable object. What is a callable object? Everything that I can invoke as a function. So I can invoke f, right? It's a function. This is a very basic thing in programming language, and I can invoke function with parameters, right? So I can do f, loading that. So it's a callable object. Long time ago, we used to have callable object that looked like this. We need to like handcraft our callable object, like a fancy callable object. And the way we used to do it is we would write a callable object function. So think about a function f, okay? So I can do something like foo f, and I can invoke foo with f, right? So think about, instead of having f, there's a syntax in C++, and you just need to remember that this is the syntax. Value, and there is this callable operator, parentheses. And I deliberately have this loads of space so you can see that it's just like I put here f. That's it. But what does it do? And I can also have an operator that get an int. What does it do? It makes my foo a callable object. I can use foo as a like it looks like a function now, right? I invoke a function. I can invoke foo with a number because I have a callable object that takes an integer. Again, I'm not doing anything, just showing you. So this was like the old way to do it. Lambda gives us, it's a bit of strange syntax, but if you just ignore this part for a second, and so this would be the simplest Lambda that I can write. I'm not passing any parameter, and this is the body of the Lambda. It's empty. But if I take a look at the macro, quote macro that the compiler is doing for me, this is what the compiler is doing. It takes this syntax and create this struct for me. And you see this operator. This is basically how I going to use this f2. So f2 I can now call it. It's just like a function. Okay, so it calls f dot operator parentheses, which is this function. And if I put here an int and I put here 3, so you see that it's going to be an int here. Because not here, sorry, on there, not here, but here. This is the name of the function. It looks funky because it's operator and there's parentheses, so it's kind of confusing. But don't be confused. It's just as if it was f. So what I showed is that it's just removes what I showed before. All this boilerplate is removed. I don't need to do that anymore. Everything that the compiler is doing with Lambda, I could write myself, but it would be a lot of writing. I need to write something like this in order to get the same effect. But instead of writing all of this, I'm writing this, again, quote compiler macro. And the compiler would do this instantiation for me. It gives me this kind of an anonymous name to the class. I don't know what the name of the class. Like I don't know. I cannot rely on it. Or this is something that this is based on LLVM. So each implementation would give their own unique name to the Lambda when they kind of parse the code. We don't care. We don't care. We just want to, we name it, we create a variable that holds the Lambda, and we use the variable just to invoke the Lambda. That's it. That's really everything. And from now, the rest of this talk would be all kinds of how to use it correctly, all kinds of keywords, like just to understand the ins and outs of the Lambda. But again, it's just it's a synthetic sugar. One of the things that I also showed before is that it makes the usage usability of Std algorithm an easier task. So before C++11, before they introduced Lambda to the language, there was a boilerplate code that I needed to write, and I couldn't put this struct foo into like inside main and use it in a template Std, let's say Std for each or Std transform. There was this limitation, and the language needed to kind of relax this limitation, and I used to have my own struct somewhere, and it was kind of detached from the context. And here I can have a lambda, and I can do a for each. I can do something like Std for each of a vector begin. Let's say there is a vector an end of the vector, and I can say, okay, f2, and it's so for each element in the vector, the function would be invoked, and the element from the vector would be passed, and something would be done if I have something in the body of the function. Something would be done with this element. So the sky is the limit. You can do anything you wish, and it makes usage of Std algorithm much more common in code base. Okay, so this is basically everything you need to know so far. Okay, there is this capture list. We'll talk about it. That I had that just before we finish, but don't worry if you didn't have a chance to review the previous one. I'll make sure that I'll repeat as needed. Okay. So the capture list. So we have these integers, and I'm printing the integers, and then I'm capturing x and y. And the way I'm capturing it is by reference. So I'm not making a copy. And in the previous session, I showed what happened when I capture. Basically, this struct or class that the compiler is generating for me would have a member variables. And in this case, there would be a reference to x and y. So basically, when I'm changing x and y, I'm changing a reference to a specific x and y. So what would happen is that let's give it time to compile. So they both started with 1, and then so I created this lambda, okay, and I'm capturing x and y by reference, and I'm changing inside of the lambda function. I'm changing it, and I'm calling. Now I'm actually invoking the function. Foo is a callable object now. I can invoke it. When I print the variable x and y, I actually changed the variable because I had a capture by ref. But here's the thing, and I explained it last time. Didn't I say that by default this operator is const by default? So let's take a look here. You see this? By default, this operator parentheses, like this callable operator, is const, which means that if I'm capturing x, I would not be able to change it because it's const. So if I want to do something like this, I would get a compiler error. I cannot assign a value captured by copy to a non-mutable lambda. So by default, everything is const. All this operator is const, so I can't touch it. But how come I actually, where is it here? I'm actually capturing it by ref, it doesn't matter by ref, but it's not mutable, and it's still able to do plus plus. So just a question, anyone has an idea why that would be actually possible? Why, although I have that restriction, why it's still possible? Let's see what's happening in the internal. I really recommend you to use C++ Insight if you have doubts about how it works and all. Okay, so it is const. It is doing plus plus, and it's captured by reference. You see this? This is the constructor of the Lambda. So why? How come I can change it? Anyone has any idea? Yes.
Is the reference just syntactic sugar for a pointer? So it's just
a
pointer.
Yeah. True. So, and I'll explain that. I have a slide for that, but it's just a syntactic sugar for pointer. So remember, const is not deep. A const function is not deep. So when you have a pointer, you have two things. You have the pointer. So the pointer is an address, right? And you have what you're pointing to. So when you have a const function and you have a pointer as a member, you basically cannot assign anything to this pointer, but you can definitely change what it points to. Remember that const is not a deep. The concept of const is not a deep. It doesn't go all the way deep to what we're pointing to. Same deal here. We're actually changing what x is pointing to, if I can kind of try to paraphrase that. I'm not changing x itself, but what it points to, and it points to kind of to some address. So this is why it's working. This is something that you need to remember, that capturing by ref means even if the function is not mutable, like the lambda is not mutable, you can change the captured variables. Yeah, one thing to remember is that C++ closure do not extend the lifetime of the capture reference. You see it a lot in, you have a stud thread, you capture something as reference, you kick off the thread and the function goes away. Now the thread is holding a reference to something that used to be maybe on the stack, died, and good luck with it now. So it doesn't extend the lifetime of the capture reference.
I was actually just bitten with that error yesterday, I think.
Yeah, you need to, if you don't get it at least once in your life, it means you're not using enough C++. So you need to use enough C++ in order to understand how things work and understand that the lifetime is not. It's a very common problem, by the way. It's a very common error, and
Right.
I've been bitten by that as well.
Hmm.
Yeah, in the beginning, when you don't really understand or you kind of, it's an oversight and all of that. So that definitely happens. And stud thread, I think takes by ref, if I'm not mistaken, and I am some cases I need to wrap it with stud ref or stud cref if I want to const in order to pass parameter to the thread function with stud thread. So that even makes it even worse. So you need to make sure that what you pass is actually would outlive and so on and so forth. Okay, so just a recap. This lambda would not work, right? I am capturing it by value. X++ will not compile. I don't know. We already saw something, so I'm not gonna look at it again. But what if we have a pointer, and I'm just pointing to x. So this is a pointer to x. Now, same deal. I'm capturing the pointer, and this would not compile. Why? It's a const. So this would not compile. So we can do this. But this would compile. And this is really basic. Again, Lambda doesn't give you anything new. You just need to understand how the compiler maps this weird syntax into something that you know from day one of C++, right? So even though it is const, px is const, not what we're pointing to. So we can still change it, okay? Okay, what about capturing globals? So I have this integer global, and I'm trying to capture it. And should I have mutable here? Can I do plus plus global? And I'm capturing, so equal means everything that I need. Please look at the enclosing scope. So start here all the way to the global scope. If you find it, capture it. Create a struct. Compiler will create a struct with the constructor and all, capturing, copying that. In this case, it's by value. So apparently, global are, you don't need to capture them. They're actually visible to Lambda without any capture. Now, you think it's you capturing it, and you think that, oh, it's const function and this should not happen, but no, it's not captured. It's actually, it is mutable, not the function, not the Lambda is mutable, but you can do whatever you want because it's not really captured. Now, remember that I told you that the best thing is not to use, in my opinion at least, not to use equal or ref. Ref means capture everything that I need in the Lambda. So look at the enclosing scopes until you find what I need. Capture it by reference, or here it's captured by value. And you can mix and match. You can say, okay, I want X by value and Y by ref, or both of them by value, and all the combinations. My opinion, and some people would have the same opinion, is that you want to be explicit. It makes your code much more robust. So you want to specify what exactly you want to capture. So if you were doing that with the global, you would get a warning that a capture of variable global with non-automatic storage duration. So it would appear only if you try to explicitly say I want global. Here, when using equal, it would mask it. So the warning would not happen. At least in the compilers that I had, maybe it's now different. In the newer compilers, I used some time back. But just to encourage you to really be specific. And this line, going back to my leetcode, should not be huge. It means that something you're using too much in your Lambda. Lambda should not be huge. So this is something that I'm slowly learning, that I want to keep my Lambdas short. Okay. How about static? So it's the same kind of type of code. Either I use it equal or specifically, and it's the same thing. So static and globals, you don't need to capture them. They are captured. The Lambda would have access to them without any need to specifically capture them. Okay. And we can actually take a look at how this would look like in CPP instead. Yes. So it's actually already upset here, so I'm gonna move it. So static int, and this is the lambda, and the lambda has access to the static int without. So that if you see here, so this is the lambda. Okay, forget about the other ones because we have a couple lambdas. We have this one, which you see there is no constructor or anything. There's just static int and be done with it. And same deal here with this one. You can see that the line number here matched to the line number. So the lambda 11 is here. But the idea is that it's not captured. There is no member data member that has static int. It just has this. It has access to the function. Sorry, not the function, but to the static int variable. So globals and static int and static are visible without the need to do anything. Any question regarding to this part? Okay. Okay, now I'm going to show some of a bit more advanced feature that you can do with capturing class members, okay? And I'm introducing a new concept which is Std Function. I have no idea why the fun is in different color. I have zero idea. I kind of copy pasted from Visual Studio. Maybe Visual Studio likes to have fun as just it's a fun thing. Std Function is it's a C++ type that it's a template type that can hold any type of function pointer, and it uses something that's called type erasure, which we can talk about sometime in the future. But the idea is that what you need to know is Std Function just can hold any function pointer. Okay, it is an expensive, relatively expensive type to use. Keep this in mind. So measure, go back to the Google benchmark and measure before you use it in your. But it's most likely it's going to be fine if you're not heavily using it in the critical path. Okay, so what we have here is the following. I have a lambda that I'm returning as a return value. Okay, and what I'm doing here is I'm just printing s. S is std string. It's a member of this struct. So I'm constructing a lambda and I'm returning it. So this is the first time that you see that I'm actually passing lambda as a return value. The thing is, if you think about it, lambda is just an instance of a class. So lambda as a callable object are pretty much first-class citizens when we want to use them to pass them around. We can pass them to function as parameters. We can return them from functions like a return value. So they are really a kind of a first-class citizen. This is something very powerful that we have from lambda, and it's really shorter than writing our own types, right? The compiler is doing it for us. So what do we do here? So these two statements are equivalent. Here I'm actually, when I have a Lambda inside a member function, a method, a member function, and I'm referring to a data member, I need to capture this. Okay, otherwise, what is S? There are two ways to capture that. One, equal, and this would be implicitly captured. Or I can say, I want to capture this, the pointer. Okay, so let's see what we can do with that. Okay, I have Buzz. This is the struct. I'm creating an instance, and I'm populating this string with this string. And then I have this B2 with a different string. And then I'm calling foo. So up to here, I'm just calling foo. But remember, foo returns a function. So when I call foo, I'm actually having a function right now. So what can I do with function? I can call it. I can invoke the function. And this is where I invoke the function that foo returns. It looks strange because I'm invoking foo, I'm getting a function back, and then I have now a function instance, and it's a callable object, so I can call it. And there is this. You can see that the Lambda doesn't have any parameters, so it's an empty. Same deal with B2, just different instance. And you see it a lot with function programming. There's a lot of you pass function around. I don't want to kind of mention a lot of terminology from function programming, but you can create a function that has some values already instantiated, and then get it and continue to invoke it with some other parameters. So this is a very common usage. One of the things that I wanted to mention is that instead of the Std function, just wanted to mention that I could also use auto here instead of the Std function. And what would happen here is that instead of Std function, the compiler would return the actual type of the function, of the Lambda function. Let me show you. Okay, so I'm expecting the compiler just returning Std function. So there's going to be a Lambda. Yeah, I need to have Std. Now, if I'm not mistaken. And IO string. Okay, so you can see that I'm just returning Std function from foo. This is the Lambda. It captured this because this is what I wanted. I wanted to capture this, so I'm capturing this. And this is the data member. It's a basic string, Std string. It's a basic string that has character traits, car, and allocator chart. Yeah, believe it or not, but basic string, it's a template with I think at least three template parameters. So foo, basically, this foo is returning, let me see. Okay, it's returning Std function that takes the Lambda. Remember, the Std function takes any callable object. It's a generic way to take any callable object. But let me see what happened when I do auto. Okay, and so auto, it's a CPPAS 14, so it's not gonna work. It needs at least 14. I can do it 11 with a trailing, but I don't have a way to trail it. So take a look what happened. Instead of Std Function, I'm actually returning the Lambda type. And this is what I'm returning. I'm creating the Lambda. This is like if I had foo, struct foo, and the instance. Okay. This is the instance, and what I'm creating here, and that's it. So I can also use auto here, and it would be much more. By the way, in this case, auto would be a preferred approach. Okay, what happens here? Okay, so you already know that there's a gotcha here. What do you think happens in this specific? First of all, what is F1? What do you think is F1? So when I'm calling buzz with some string .foo, I'm getting something back. So F1 is a Std function, right? And F2 is also Std function, and it's a Std function, so I can call it. But what happened when I do this too? So the problem is that, and we can take a look at Callable. We'll get an kind of an undefined behavior. I only got the last one. Basically, got unlucky that it didn't crash. It's an undefined behavior because what happened is that when I'm done with this expression, this temporary that I created is gone. So F1 is already looking at something that it's on the stack and all, but it's gone. And then I do F2, and we see just the stack has only like pointed to the same place. So F1 and F2, it's like they'll print the same because it's just the stack layout is only having the ULA one. So it's undefined behavior, and unfortunately it didn't crash. So remember that when we return, when we move functions around and they capture this, you need to make sure that this would outlive the function, the lambda that is capturing this. And again, it goes back to the same thing with Std thread and that I mentioned and all. When you start, remember, nothing is prolonged. Each entity has its own lifetime. So you need to be aware that if you capture this and you start moving this lambda around, those Std function or whatever that is holding this whole instance, you need to make sure that the references and the pointer and all that, they still point to a valid instance. Lambda would not prolong anything. No magic here. And this is basically the explanation of that. And here's another example, okay, that has nothing to do with Lambda. So you have bar, and I'm instantiating this string, and then I'm calling foo, and I'm returning a reference to this string. It's a auto ref. It doesn't matter. It's not going to prolong that. At the end of the expression, this whole thing goes away. So that's something that you need to remember. Try not to do this stuff. It's very dangerous. Like a temporary, that's something. It's not going to prolong that. There are specific rules how to figure out what needs to be prolonged and what is not. Now, this like star this is going to fix it. Why? Let's see. So I'm not capturing this. It's a C++ 17. I'm capturing star this. So what actually happened when I capture star this? Why here it looks fine now? And okay, the reason is that we're actually making a copy inside the Lambda. We're actually creating a buzz and copy everything to it, and the Lambda now owns its own string, and it's kind of detached from the buzz ALA. So when I call foo, this ALA would be copied, and we can definitely take a look at CPP inside because that's be interesting to see. So let's take a look. Okay, so basic string S. We have the Lambda here, and we instantiate with star this. And so buzz would be just a copy of this whole this. So this string that used to be in this is now copied. So I have my own I have my own buzz copy now, as opposed to this part, which I actually have a pointer to some this, and this would go away. But when I actually have an aggregation, I'm aggregating buzz, so I have my own copy. So I don't care that what I copied from went away. I'm actually have a copy of everything, including the std string, so I'm good. Does it make sense? Yeah. Okay. Any question regarding this part?
Will the slides be shared?
Sorry?
Are you going to be sharing the slides?
Oh, yeah. Everything is going to be shared, yeah.
Okay.
I'm sick and tired of these slides. Believe me, I'm going to share everything.
I was wondering if you know what would happen if we used it like explicit?
If we use explicit, where? In which part?
Like on the previous, maybe, and if you could go to the compiler explorer, previous one. You don't have a copy constructor.
I actually don't have anything here. But you're saying if I had a constructor that takes S, for example, that's what you're saying?
Yeah.
Okay, easier to do it here. So what you're saying is, do you want to start this or not?
No.
And what you're saying is the following. We'll have explicit root string, let's say S1, and do S. S1. Okay. Some reason, yeah, okay. Horrible things happen here, as you probably see. I hope I killed it. I didn't kill anything here. Okay, so it compiled and all. There's nothing weird happened. I don't know why. I just need to think about it. Why adding a constructor would have this horrible thing. I'm doing and it's truncated, so it's even bigger. I'm doing something very bad with the stack, and I don't know why this would create it. But what did you want to see? What was your gut
to be
feeling?
honest with you, not really a gotcha or anything, but I was trying. I think it was Jason Turner, he uploaded like a new video on his channel explaining like why, how explicit could be used to reduce copies.
Yeah. Yeah, I don't think there is any copy here happening. This is an aggregate initialization, so you don't even need any constructor here. I'm trying to think what happens if I do like why actually to do that we need to have a very good look at the assembly code, and it's better to remove the IO stream because they are cluttering all this. It's really hard to read, and then we can see why it's miserably failing. Something with the stack is really getting super bad. One of the things that I wanted to show is I have in the next slide is another trick with this, but it's going to be in another few slides. So give me let's wait another few slides to see that. Okay. So I already talked about mutable versus immutable Lambda. So by default, they are mutable. They are immutable. And by using mutable, we actually removing this const. I think it's one of the first, or one of the fewest syntax construct that the committee did correctly, like const by default, which we really like. Not a lot of things would look like this. We already talked about this. This is just the same slide, but in a mutable versus an immutable one. Same here. We already talked about it, so I'm going to kind of skip that. Here's a very, very, very interesting use case. So let's say you have an int const int or int const doesn't matter. And I'm passing that by value. So if you capture a const variable, the constness is preserved even if you put mutable. This is an outrageous, I know, but this is life. X is immutable, and if I run that with this type trait is const, you'll get decal type would give us const int. It would be yes, it would be true. It would be 1. This is something that I discovered some time back, and I just memorized it, and that's it. Okay. Now let's talk about move-only objects. So some objects. So C++ 11 introduced this move-only. Not move-only. Move semantic. So some classes they are move-only. What does it mean move-only? You cannot copy. You cannot make a copy. You can only move. You can only move when you want to take a specific instance and assign it to another instance. You can't make a copy when you assign it. You can only move it. Like the ownership would be moved. Unique pointer is an example. Is a very good example because unique pointer. Looking at the name, it's unique. So it's only one owner would use it. So this would not compile because we're trying to make a copy. But C++ 14 gave us a very nice syntax to walk around. And in this capture section, you don't only able to capture stuff. You can actually define new data members for your generated class from the Lambda. So going back to this part, I could actually do something like S equal this S. I could actually make a copy. Compile it. And it works. So this undefined, it used to be undefined behavior, right? But I can actually, and I know it's confusing because I'm using S here and S here, but it's fine. I could do, if it's not going to compile, but I could do S equal S. Like I can take an S and change it. Actually, this compiled because S is this S, so it's fine. So what I'm doing here, I'm taking this arrow S, and I'm making a copy into a new S, and the type inference works. And here I have a copy now. Let's take a look how it looks in CPP Insight. This is a very powerful C++ 14. Okay, so here's the constructor. I'm actually making a copy in my, I'm making a copy of S here. And that's it. Yeah, the previous disk can go away, but I don't care. I have S copy of it, and I'm done. Super powerful thing in C++ 14, because I can remember what I showed in the previous section. There was this iota and there was generate, and generate had n equal in the capture. It had n equals 0 or something. I don't know if you remember, there was n equals 0. So I can actually create any variable, and this is going to be an int. And I can do, hey, I want to unsigned long, so it's going to be an unsigned long. So this, and I'm not capturing anything from outside. I'm actually creating my own data. I'm creating my own data members. It's a very powerful syntax. So going back to how we fix that, I can actually take P, std move it into a new P. And yes, I can use P here and P here. Kind of shadowing works perfect. And I moved P, I'm not copying it, and I can use it internally inside the Lambda here. Okay. Let's talk about return types. Return types are inferred. You don't really need to say, oh, the return type of the Lambda is this and this. You could, if you want to force it. For example, if compute is, I don't know, double, and you want to force it to be an int, you can say, I'm actually returning int, and it's going to be custom to int, and things like that. It's basically implicit, like return A less than B would be the Lambda function would return bool. So the compiler is really smart to understand what's happening. Now, the compiler would be upset if it cannot deduce the types. Let's take a look. So what I'm doing here is I'm having either x times something, or I have a string. And the compiler, hey, I cannot understand what you're doing here. I have double, and I have const char pointer. I cannot deduce the Lambda return type, so it's not going to work. So the compiler needs to have something easy to deduce from. Even if it's a huge Lambda, it doesn't matter. But you cannot like return some type here and other type over there. That makes sense, I hope. Okay, one of the things that you might hear is IIFE. This is immediately invoked function expression. It's a very simple concept, but powerful. And the reason it's simple is that the following: X and Y, I'm capturing by reference everything, and then I have this Lambda. All up to here, it's a Lambda. So up to here, I have an instance of something that is a callable object, and I can use it. I can actually call it here. So the first time I've seen this was Herb Sutter talk like long time ago, when he said, okay, how can you create a const variable that you want to initialize once, but it depends on, let's say, some operation. So you basically assign it to a function, but if it's something like, sometimes it's like if A, then have true, else false. So you can have it inside a very short, either several lines or very short lambda, and you immediately invoke that at the same time. And there is a link here that I recommend you to look at from this person that Bartek, that I mentioned his name. He has very good books. So, and if you subscribe to his blog, there's tons of stuff that you can learn from. So it's a simple concept. There is nothing really to have more, but it's being used in a lot of contexts that helps to do all kinds of magic. Be aware of that. Okay, things that Lambda function can do, they can decay to pointer. And they can decay to pointer in one condition. They are stateless Lambda. Which, sorry, not stateless, not capturing Lambda, I meant. Non-capturing Lambda is a Lambda that doesn't have any capture. And so this, for example, is an example of how the Lambda would look like. And I have this function that takes a function pointer. The variable name is bar, and there is a function pointer type. Okay, and I'm taking bar and invoking it with, let's say, 10. That's the integer here. So both of these are equal. I can take this instance and sorry, and invoke that with bar, because it has an operator that casts to a function pointer. And I can also take this function, Lambda function, and pass it to this this function that takes a function pointer as parameter. Now, why it's useful? It's useful because if you want to interface with C function, like a pure C function that takes a function pointer, you can use non-capturing Lambda. You might need to use plus sign. This is like kind of a secret sauce syntax to force the compiler to decay it into function pointer. But a non-capturing Lambda is a function pointer. And let me show you something. Okay, so you see this Lambda? There's a lot of code here, but it's very simple. The body of the operator is nothing, because I have nothing here. Then I have a type def of a function pointer that returns void, function pointer, no parameters. Okay? And I have a static function called invoke. And I have a cast operator to this function. So basically, if I have an instance of this and I try to cast it into a function pointer that returns void and takes no parameter, this function would, this cast function would kick off and returns invoke, which is a static function. That's it. Now, if I had something like int x and I do return x, you'll have more beef here. So it's non-capturing. So I have all these goodies happening. So this function would invoke this invoke, which is the same as this return. Both of them are doing return x. Now, what happens if I do plus? We can see that I'm forcing it to. It's a very kind of cryptic syntax, but if you think about it, it's a static cast of this whole cast operator to a function pointer that return integer and being passed integer as a parameter. Okay, so that's the whole thing. Now, what happened if I have if I'm capturing? See what happened. All this stuff went away. That's it. This lambda is a capturing lambda. It's not going to be decayed to pointer anymore. So I can't do something like cannot force it or anything like this. It's going to be an error. There is no such thing. So non-capturing lambda are very powerful for interacting with C functions, like pure C function that accept just a function pointer. So we can actually interact with legacy C code if you have a non-capturing lambda. Let's remember that. Okay, C++ changes. I already mentioned this, so this is not new. Capture with an initializer, that's the name. So I can have 10 and 11. I create Z, capture Z as x plus y, and when I invoke foo, I'll get 21. Very simple. And same deal with here with this. I cannot copy, so I cannot put pointer. I can move, so I can move the ownership here and use it. This is a compute optimization to show you the powerful of using this feature. So in the first one, I want to find. So I have a vector of strings. So I want to find if any of the strings in the vector has foo bar. So the author of this function, what the author did is returning this lambda would return a bool, right? This is what find if is looking for. So S would be every index from the vector. So 0, 1, and it's being passed. So we check each and every index, and we take foo. This S is a string literal. It creates a std string from foo. So it takes both of them and concatenate and check if it's equal to S. Now this concatenation is done for every single loop. Every find if is a loop, right? And this is the body of the loop. Not everything in the body, but that's one of the things. What if we could actually cache this once and just do is S equal P? So this is possible now with C++ 14. I already mentioned that, so I'm not going to repeat. This was another way to solve the other issue with the dangling pointer. I'm actually making a copy. So every dangling pointer and all of that is, okay, I make my own copy and I don't care about dangling anymore. That's a solution that you should be aware of. So that's how C++ 14 provides us this solution. One of the biggest things that I like in C++ 14 in all the, so C++ 14 is a kind of a bug fix of C++ 11, but one of the major things that I like in C++ 14 is generic lambda. Generic lambda allows me to have the keyword auto in the parameters. Why? What happened here is basically this function become this lambda that, this is what the compiler would do for us. But instead of operator of something concrete, it becomes a template function. So it's a generic lambda. I can use foo with 10. I can use it with like an integer, with a double, with a string, and everything would work. This std out would work as long as there is a std out for int, double, or string. So it's really comfortable. It's another step toward generic programming, but the best thing is when I'm using it in stud algorithm. So when I have stud algorithm, this is let's say I have this map. So I'm initializing, it's a map of string and int, and I'm initializing it with 3 elements, 1, 2, and 3. So 1, 1, 2, 2, and 3, 3. What I'm doing is I'm iterating over these elements, and each element of stud map is a stud pair. Okay? So naively, kind of in a naive approach, I'm writing const because I don't need to change it, so it's const stud pair, stud string, comma, int, and the entry. And it's a const by reference because I don't want to make a copy of the pair. I just want to see out it. Now, first of all, let's agree that this is long. Like, it's easier to have const auto ref, right? So it's easier to have something like this. I hope everyone agree here, okay? There's another issue here. Anyone remember what's the issue? I was bitten by that once, and I memorized it and not bitten by it anymore. But I'm using also auto, so I'm usually using C++ 14 and above, so I'm not even need to worry about it. But what's the issue here? Guess. Try to guess. Okay, so the issue is that what happened is that the key value, the pair that's being in the data structure of studmap, the pair is actually doesn't look like this. It's almost like this, but not 100%. It's not identical. It's similar, but not identical. The stud pair that is being held in the data structure is stud pair of const stud string. It's a const key and then the value. So let's think what happens here. I have a const reference to stud pair of stud string and int. Because I'm saying, hey, I'm gonna be smart. I need a const and I don't need a copy, so I'll make a reference and my performance would be awesome, right? What happened here is that const stud pair of stud string int ref is not the same as const stud pair of const stud string comma int ref. So compilers say, hey, I can't really have a reference stud pair of const string int and stud pair of stud string int, 2 different types. This one keyword makes a whole new type. It's not like a similar type. It's not convertible. It's a new, not convertible in the sense that I cannot. It's not the same ref that I can. I can't do anything, any ref to it. I actually need to make a copy. I need to create a stud pair, a temporary stud pair, that copy the stud string and copy the int, and I have a new stud pair. And now I have a reference to a temporary. I have a const reference to temporary, which is fine. I have const reference to our value. This is legal, but I was thinking that I'm smart and I'm gonna have this performance benefit, but I'm actually not. I'm actually making a copy for every single for each loop. So this is bad. right? And how do we fix it? We use auto. And I can actually use const auto here. I don't know why I didn't do that. But we use const. And auto, as you know, it's gonna generate the same code. Everything is good. But I let the compiler do the right thing. And this is one of the benefit of auto is that the compiler will do the best thing. So use auto as much as possible if you want to get a better type deduction and you not want to get into this pitfall. I'm basically done. There are a couple of slides that are related to like a more advanced, this is just a couple of slides of them, more advanced stuff in related to Std Function and Lambda and functional programming. Remember that they are first-class citizens. So further reading for you, an example, the book that I mentioned in the beginning is one good resource. You can pass a function to another function parameter. You can assign function to variables. You can store them in Std Function. You can create new function from existing function at runtime. There's so many things you can do. It opens a lot of like this. The functional programming never been so flourished as we have since C++ 11. In C++ 20, we can actually have this nice way to declare another copy of the Lambda. We couldn't have it before C++ 20. And the C++ 17 cookbook has a lot of things related also to Lambda that I recommend. And the last slide has a lot of stuff. For example, this Lambda Stories book on LeanPub is a great one, by the way. It's definitely worth the money. From 98 to C++ 20, it has everything under the sun. I can show you really quick. Lambda stories, where is it? Previous one. Here it is. Okay, so take a look at the table of content. So he explained about 98, 11. Here is immediately invoked function that we talked about. C++ 14, 17, and 20. We didn't really cover it. Covered a lot of C++ 17 and 20. We did mention capturing of star this. There's some updates to the immediate invoke. This is the examples that I showed. Template Lambda are new things that you can do. Capturing parameter packs. This is template Lambda. So a lot of things happen, which I recommend you if you have a chance to take a look at this book. This is a very, very good one. Okay, that's it for today. You have any questions or comments or anything you want to talk about?
What was the other book, the packed book with C++ functional programming?
Yeah, it was, I'll show you. 1 second. This one, learning C++ functional programming. I really liked it. So I recommend looking at it.
Thank you.
You're welcome. Thank you, everyone. See you next time in our Safe Code Warrior thing competition or tutorial or tournament. Take care. Bye-bye.
Thanks, Kobe.
Bye bye.